All right, let's get into it. Today, we're going to talk about a new AI model that isn't just another chatbot. No, this one's different. It's built from the ground up to tackle one of the biggest headaches holding back truly smart AI agents.
So let's just jump right in. What is the big problem here? Well, if you've ever tried to build an AI agent that can actually remember things, use tools, and handle a complex job over time, you know it is just crazy expensive. And it all boils down to this one fundamental trade-off. So you've got this choice, right? On one side, you have your small context models. They're super fast, they're cheap, but they basically have the memory of a goldfish. On the other side, you've got these long context models. They're brilliant, they can keep track of everything, but the bill just goes through the roof the more you ask them to remember.
And that gap, that painful choice between being smart and being affordable, that's what we call the agent problem. This is exactly where DeepSeek v3.2 steps onto the scene. It's not positioned as just another model, it's a specialized agent model designed specifically to solve this problem.
So how do they pull this off? Well, it all comes down to three key ideas that work together. First, a totally new architecture. Second, a huge investment in the right kind of training. And third, a pricing model that just changes the entire economic equation for developers.
Okay, let's get into the nerdy stuff, because this is the real secret sauce. It's a new method they call DeepSeek Sparse Attention, or DSA for short. And it's how you get a massive 128,000 token memory without, paying for 128,000 token memory. So, to really get why this is such a big deal, you gotta understand how things used to work. The standard way, vanilla attention, is kinda dumb. Imagine you had to reread an entire book from page 1, word for word, every single time you wanted to add a new sentence. It's insane, right? The cost just balloons, and by the time you get to a long context, it's just completely impractical.
DSA just flips that whole idea on its head. It works more like you or I would. You don't reread the whole book. You quickly skim the table of contents, you find the 1 or 2 paragraphs that are actually important, and then you focus your full attention on just that tiny piece. It's a much, much smarter way to work.
And it boils down to this really slick 3-step dance. First, a super fast indexer zips through everything and just scores how relevant each piece of information is. Then, a selector comes in and says, okay, just give me the most important stuff. And finally, that expensive, heavy-duty attention process only has to run on that tiny, pre-selected handful of tokens.
So what's the magic number here? Out of that huge 128,000 token context window, how many does it actually focus on at any given moment? According to their report, it's only about 2,048 tokens. That's it.
And that is, wow. Think about what that means. The model is intelligently ignoring about 98% of the context during the most expensive part of its thinking process. It's filtering out the noise to focus on the signal. This isn't about forgetting stuff. It's about being incredibly smart about what to pay attention to. That's where all the savings come from. Okay, so that's the cool tech. But why does this actually matter for people trying to build things in the real world? Well, this clever bit of engineering translates directly into a massive economic advantage. And it's not just about the fancy architecture. DeepSeek did something else that's really important. They sunk more than 10% of their entire pre-training budget into the post-training phase. Now, that might not sound like a lot, but in this world, that is a massive investment. It's this step that really teaches the model how to reason, how to use tools, and how to act like a real agent, something a lot of other models skimp on. So you do all this clever engineering, you spend all this money on training. What's the result? Well, check this out. It's a straight-up price disruption. The cost to use their API got slashed by over 50%. This is the direct payoff of that smart DSA architecture.
And look, cheaper tokens aren't just about saving a few bucks. This changes the entire game for what's possible. You can now afford to let your agent try things, fail, and run self-checks to get it right, because the retries don't cost a fortune. You can stuff way more raw information, code, logs, documents into the context, which just makes your agent more reliable.
So with this new power and this new price point, whole new classes of applications have just opened up. So let's talk about the playbook. What can you actually build with this?
Right. This is the big question, isn't it? What kind of really valuable applications, stuff that was just a pipe dream yesterday because of the cost, are actually doable now? Okay, here's a big one, a code-based refactoring agent.
Think about an agent that can swallow your entire codebase, understand all the messy connections between files, and then intelligently refactor it for you, all without you having to mortgage your house to pay the API bill. That's now on the table.
Or how about this? A research agent. You could feed it, I don't know, 20 different dense scientific papers, and it could actually read and understand all of them at once, pull out the key insights, find the connections, and write a novel summary with perfect citations. That was basically science fiction for most projects before this.
So if you're itching to build something with this, here are the key things you got to think about. First, you need to pick the right model for the job. Then, you absolutely have to model your costs for your worst-case scenario. Be really strategic about what you put in that 128K window. And most important of all, test it. Test it on your own real, messy, ugly data. So what's the big takeaway from all of this? Well, what we're seeing here is this incredible convergence. The idea that powerful, open-weight models and truly capable agent-grade models are finally coming together. It's making reliable, sophisticated agents something you can actually afford to build and run.
And that really leaves us with one last huge question to chew on. The cost of this kind of long-term reasoning is just plummeting. So it's not about if we can build these super smart agents anymore. The real question is, when the cost of this kind of intelligence gets this cheap, what are you going to build with it?